Hello, welcome to the Cisco Live Master Series. In this session, we're going to be talking about meshing with your mess. My name is Shannon McFarland. I'm a distinguished engineer focused on cloud networking and other cloud native technologies such as Kubernetes and service mesh. Today we're going to talk about the service mesh. What does that actually mean when we look in microservices and application deployment? Then we're going to get into what a service mesh is and why you may want one. And then we're going to pick one particular example of a service mesh, LinkerD, and we're going to talk about the architecture of it, the design of LinkerD, how do you obtain it, and then we'll walk through a live demo of what LinkerD would do with a specific sample application we have. Then since LinkerD is an open source technology, we're actually going to talk about contributing to the open source technology within the community. And then we're going to wrap up with deploying meshes on the Cisco container platform. So the service mesh. Before we get into microservices and the service mesh solution to some of these problems, we kind of talk about the monolithic application where most of the applications historically have been. Where you are taking a single executable or a single binary and you are wrapping all of the infrastructure components such as logging and a web interface and databases into that monolithic application. Then come along the microservices architecture. So within the microservices application framework, you break each of these monolithic components into discrete individual kind of bite-sized components. So you have web, you have logging, you have databases and so forth, but they are broken down into smaller, more easy to manage services. But when you do that, you create a network of these services. In fact, that we've got to still deal with each of the services themselves, but now we have to account for how they're connected to one another. So when we look at scaling a microservice application, we first look at how we used to scale monolithic applications. So we tend to have kind of this scale-up model where we would wrap more resources around that monolithic application. We may add more CPU or more memory or more network or more storage to make it more performant based upon the load. We may also scale it out, create more versions of it, and then create a network of those applications, maybe via load balancer. When we build a microservices application, again, we have smaller bite-sized chunks of that application, but we use something like Kubernetes, which is a scheduling and kind of placement tool that we have at our disposal for the microservice side, and we begin to just spray those services around based upon specific criteria. But as we do this and we scale out those applications, we create even more interconnectivity and more resource requirements as it relates to how we distribute traffic and how we gain access to these applications. So the problem enters in when we begin to deploy service features for each of these microservices. So we can see here on the top right-hand side that we've got kind of a three-part application built of three different microservices. We've got a web server, we've got a payment service, and we've got an order management service. And what happens in a microservice world, and it's an actual benefit, is that we actually can have different teams, even different companies, develop using whatever framework, using whatever tools they want for each of these components. So one part of this could be Python, another part could be Node.js, and so on. But what tends to happen in a lot of these kind of divide and conquer models in the microservice world is that each one of these teams begins to develop all of the infrastructure and service features for their own thing. So that could be their own version of logging, their own version of load balancing, their own version of security and trust. And then when we begin to scale that across each one of these microservices elements, we can see that in fact, it becomes very difficult for us to actually get a singular view of everything that is happening in this application because logging and metrics and tracing and so forth may be disjointed. So when we start to lean towards this service mesh technology is when we begin to offload some of those features into a service-to-service communication element, and this is what we call a service mesh. So we still have the same services. We've got web servers, we've got the order management, we have the payments. but we take some of those service features and we deploy a service mesh that is responsible for taking care of all of those individual components on our behalf. So it is taking care of authentication, it is taking care of load balancing, and so forth. And so we will expand upon this idea of a service mesh taking care of some of these infrastructure components so that the application development team does not have to inherently write that code for each one of their applications. So for the sake of our discussion today, we're going to take a look at an application service requirements list. And we're going to build on this and then eventually demo what this would look like inside of a service mesh. So we're going to assume today that I want to deploy my application on a microservice. And I want to deploy that microservice using Kubernetes. And then I have a bunch of individual service requirements that I need to handle. I need to be able to deal with service failures. I need to be able to deal with retries, but I need to intelligently deal with retries in such a way that after a certain time I kind of give up so I don't create a retry storm. And there's many other things that we'll talk through, circuit breaking and tracing and so forth. So let's define a service mesh and then let's build a service mesh. So simply put, a service mesh is an infrastructure layer for service-to-service communication. So if we take a look at our topology here, we may have users or tools or a service that is consuming our microservice application. And we may be entering that through a load balancer or an ingress of some sort. Prior to a service mesh deployment in this picture, we would have each of our individual service components, maybe the UI talking to the payment service, and they would be speaking to one another directly. Well, since we're building this microservice application on Kubernetes, we use this concept of a pod. And a pod is just simply this abstraction or this component that we put more than one container into. In this particular view, we have the main body or the service container listed in blue. And then in the service mesh deployment, we do something what we call injection. We inject a sidecar proxy. Now, sidecar proxies have been around for quite some time. What makes them interesting in the service mesh piece is not only is the sidecar proxy doing stuff on behalf of the application, but we are also wrapping a control plane to better manage and create visibility of each of these sidecar proxies. So we're going to use this theme throughout the rest of our session together and kind of look at what are all the architectural components that make these things up. So quickly, what are all of the service mesh options out there? There's a lot of hype around each and individual one because there's alignment with some versus another based upon the community that you're associated with and even based upon the organization you may be associated with. Today we are focused on application service meshes. These are service meshes that are dealing with applications from layer 4, like TCP, all the way up to layer 7. So you can see the list here, things like Istio, LinkerD, which is one of them we're speaking about today, and many more. There are also other types of service meshes out there. So network service mesh is focused on similar types of problems, but they're really aimed at layer 3 connectivity. And then there are the historical types of service proxies and API gateways that have been around for quite some time. So let's pick one of those service mesh types, LinkerD, and kind of build on what it does and how we would use it. So LinkerD is a service mesh project in CNCF, or the Cloud Native Computing Foundation. And this is an organization that handles many big ticket open source projects, things like Kubernetes, Prometheus, and many others. So LinkerD has been around for a while, and you can see kind of the short list of customers that use it from day to day, to include Cisco WebEx. And it is growing in popularity and got a very strong community. So what does it do? Well, these particular items that we see here in this slide are not necessarily just specific to LinkerD. Most of the application service meshes try to accomplish these three things. So the first one is observability. We want to be able to create a service level view that includes successes of each of our connections between every one of our microservices. What are the latencies between those things? What are the throughput criteria associated with that? And then finally, we want to have a service topology that shows us graphically the flow of traffic and what all the dependencies are in our services. The next is reliability. We want to be able to, based upon a policy, identify how many retries, when do we do retries, Timeout values, how do we do load balancing? Maybe we want to spray traffic from one part of our deployment to a different part of our deployment based upon a canary release, maybe a new version of our application. And then finally, we also want our service mesh to kind of offload the requirements we have with things like mutual TLS or mutual transport layer security. This is dealing with encryption. But not only is it dealing with encryption, it's also dealing with trust. How do I know that one service communicating to another service is who they say they are? And so these are the types of things that a service mesh deals with. And then finally, we want to wrap all of that up into a very ultralight package. As we'll talk about in the next slide, it's very important for us to ensure that we are not injecting latency into the application itself as much as possible. So this is exactly what the LinkerD design looks like. Is in short, we want to do less, not more. When you begin to crawl up the application stack, especially at layer 7, you have all types of capabilities of getting involved in the flow of those communication processes and doing magical things. The problem of that is the more you get your particular tool or service mesh or proxy involved, the more you can inject latency, the more you can delay certain legs of your application, and the more you can create complexity. So the LinkerD design is focused around doing just what you need to do to make a service mesh work. And you want to do that from a zero config perspective, meaning that you do not have to refactor your Kubernetes-based application to make LinkerD function. The other thing that we talked about in the last slide, which make them ultralight. We want to be able to introduce these components, both the control and the data plane that we're going to talk about here shortly. We want to do that in the most efficient and least impactful way. So when we look at the control and data plane, which we're going to talk about here in the next couple of slides, we look at a very low impacting components. We looked at the control plane, which is written in Go. We look in the data plane, which is written in Rust, which is a super efficient environment. And so we can look at something like sub 1 millisecond delay when we put a sidecar proxy in the delay in the path of this. We're really not negatively impacting the application. So let's take a look at the LinkerD2 architecture, and then we're going to break some of these components down into smaller bite-sized chunks, and then we're going to show them in the demonstration. So in this particular slide, we're looking at LinkerD2. There is a LinkerD1, and it was built on what we call the Twitter stack. It was very JVM focused and had basically it was not aligned necessarily to Kubernetes and so forth. So LinkerD2 is again comprised of a control and a data plane, as most service meshes are. And we've got several components here, and a few of them we'll mention here, but we're really going to talk to each one of them in detail in the demonstration. So first off, we have a CLI and a web interface that are talking to the public API, and we're going to work with both of those here in just a moment. Then we have the tap component. We'll also see that in the demo, but the tap component in brief is a way for you to take live detailed flow information from layer 4 through layer 7 and tap into those flows. We can see things like gets and post and so forth. The destination component is where the data plane or the proxy or the sidecar is going to find out where they need to forward or route particular requests that pass through them from the application. Identity is pretty self-explanatory. That's where we're dealing with encryption and trust. The proxy injector we'll actually see in our demonstration. That is the component we use to inject the sidecar into the actual application flow itself. And then Prometheus and Grafana, these are two monitoring technologies that we'll actually look at in our demo. And then finally, down in the data plane, it looks much more simplistic, but the data plane actually carries the load of the service mesh. It is the thing that is there speaking on behalf of the application itself. So it is taking in layer 4, taking in layer 7 information, and doing something with it. And so we'll talk through that as we move through the demo. So LinkerD, how do I get it? Well, getting it is pretty easy. So you go to linkerd.io and you can begin through the getting started page, and you can actually start looking at what features are in which releases and which one you might want to obtain. And because LinkerD today, LinkerD2 specifically today, is built to run on Kubernetes clusters, you would go out and deploy a Kubernetes cluster. you would deploy the LinkerD binaries, and then you would deploy or add LinkerD to your microservice. So the next few slides, we're going to kind of show some animation of building a cluster, installing LinkerD, and then deploying a sample app, and then we'll switch over to a live demonstration after that to kind of work through what is it the service mesh is actually doing for this application. So we can see in this particular example, we're using the Google Kubernetes engine, GKE, to deploy a cluster for us, and so we can see the clusters up and running. And then we're going to go out and do a get credentials so that we can actually log in and do stuff with our cluster. And then finally, we're going to go out and create a cluster role binding. This is a way to give us RBAC, or role-based access control, to actually do things with the cluster based upon specific permissions. Then next, we're going to do the LinkerD setup. So most of the service meshes out there, you're just simply curling an install script. It downloads local to your machine, and it's just installing the client library. Once you do that, you export the path to go gain access to that particular file, and then you run a pre-check against the cluster we just built, and it's going to go through and make sure that LinkerD can be installed in your Kubernetes deployment. What's happening now is that we're actually installing LinkerD in the cluster itself. So it's doing things like deployments and cluster role bindings and service deployments, and it's basically building all of the things we looked at in that infrastructure slide. Then once it's installed, we do another check to make sure that LinkerD, in fact, is running as we want it to inside of the Kubernetes deployment. So finally, we can take a look at a kube control, a git deploy, and actually look at all of those different LinkerD components that we looked at in the architectural view. So the destination and Grafana and the tap and the web service and all of those things in our environment is up and running. So finally, let's go ahead and install a sample application. So there's a book application out there that we're deploying and we're going to engage with here in just a moment. So we basically go and install it just like we would any other Kubernetes-based application. We're going to wait for that deployment to come up. And then once it comes up, we're going to then do that injection thing that I talked about a few slides ago. So that LinkerD inject is simply saying, here is an existing application that was just deployed, inject the data plane or inject the sidecar proxy into each one of the microservice components that comprise this application. And then the next thing we want to do is we want to do these kind of per route metric type things. And so we do this by using OpenAPI or Swagger components that are basically things we know about our existing application, and we create a LinkerD service profile. And these service profiles are in fact just routing rules, but they're not routing like you would expect in like a Cisco router. These are kind of layer 7 routing rules that say how to gain access to very specific parts of our microservice application. And we can see in this case, all of the successes are up for the things that we're trying to engage with. Cool. So we went through that process and we've got our cluster up and running, we've installed our application, and so now we're going to switch over to a live demo here and actually take a look at what LinkerD is actually doing to our application. So as we switched over to our live view here, basically we're taking a look at the LinkerD cluster that we have deployed inside of our Google Cloud platform, and we can see that it's up and running. We can see that we've got a list of workloads. Those are all those things that comprise of our microservice application, authors, books, and so forth. And we can also see that we've got an entire list of all of the LinkerD control plane components. We also see that we have created a bunch of service objects. These are all standard Kubernetes types of things that we can see listed in here. And we can see that through our application deployment, our web app already has a public IP address, and if we click on it, we can now see our actual application. So this is a pretty simple sample application. It is a web app that we're looking at, and that web app is actually going out and talking to the books microservice and the authors microservice. So we can engage in this environment and enter someone in here, add an author. We can add a title here. Put a book count. And we can see it's a functioning application. We can actually now see that, that our author and our books are there. So now when we go over to the LinkerD UI, if you recall, there's two ways into our public API. There's the UI and the CLI. We're going to take a look at both of them. So we're not going to walk through all of these different elements, but some of the big ticket items that we want to look at is, for one, we can see all of the Kubernetes namespaces that exist in our cluster. And in our particular case, our application is actually deployed in this default namespace. We can actually see it'll start as traffic enters here, we'll actually start to see it paint itself out. But we can actually take a look at all of the deployment. This is everything that makes up our microservice environment. And we can actually go over and see all of this same thing inside of our CLI. So inside of our CLI, we can go in and engage with our Kubernetes cluster, and we can see the same types of information. And we can also engage in the actual LinkerD API itself by running the actual LinkerD command. So we can see here that we've got our web app, we can see what's in the mesh, we can see what the latency looks like. And if we take a look in the UI, we can see the same types of objects. So now let's drill a little bit deeper into this environment. So from the web app perspective, we can actually see that we have a traffic generator that is generating traffic to the web API. And then our web app here is actually talking to the various components of that web page, the books, the authors page, and so forth. Now here's what's really cool about a service mesh. Is in a service mesh, we are getting layer 4 through layer 7 real-time statistics. So we can actually see this information is being updated in real time. So we can actually see layer 7 information like gets and post happening in real time. So you're not having to capture this information or go dig for it way down at a packet capture. You can actually get this in real time. So we can click on some of these things and we can see what service is talking to what service, what pod's talking to what pod, and so forth. And we can even create a tap. So taps are great when something's going wrong. So if you have maybe a new version of your microservice application that someone just published into your Kubernetes cluster, and then all of a sudden your delay goes through the roof, and maybe someone's calling saying that something is slow performing. You can click on a tap and actually generate real-time flow information. You can do it by CLI as well. And we can actually see all of these gets and posts that are happening between the web app and all of the things that the web app is talking to. So we can actually go in and see all of the requests, all of the responses, and so forth. So pretty cool information. Also, when we kind of take a look at another way of viewing this, we can look at the Grafana and Prometheus part of our service mesh. So built into the dashboard is the Grafana view. And we can look at the success rate, the request rates, all the inbound, outbound types of traffic. And we can see that on a per deployment basis. We can even see all of the pods individually as they make up our microservice application. And so we can go into a particular pod and take a look at all of the things that it's speaking to in its live calls. And we can also pull up Grafana individually for a specific pod. So that is pretty cool. Now, one thing that we want to kind of dive into here real quick is when we refer to the sidecar proxy part of our implementation, that is one of the most important elements of any service mesh is that sidecar proxy, because it's the thing that's getting in the middle of our microservice environment. So let's take a look at a particular view of a pod and see what a pod is comprised of inside of our environment. So we're going to take a look at the author's deployment here. And we're going to come back to our Kubernetes dashboard, and we're going to click into authors. And we're going to see down here, there's all the statistics that you can look at, but we can see that this deployment is based upon 3 pods. We asked for 3 pods and we got 3 pods. So let's click into one of these pods. We're going to scroll all the way down here, and we're going to see that it actually contains 2 containers. We have that main body service container that we talked about. This is the thing that's actually running your application. And then there is the LinkerD proxy. If you are looking at an Istio environment, you would see an Envoy sidecar proxy and then this service proxy. So most of the application service meshes that do sidecar proxies, this is the way they're done. So this is really how things happen. Now what's really cool about this is that once the service mesh is in your cluster or the service mesh is in your application, the last thing that we're going to show here is the fact that as you need to scale out or shrink in your cluster, the service mesh just grows along with that. So if we come back here and take a look at our list of workloads, we can see Authors has 3 of 3. So we asked for 3 pods, we got 3 pods. So normally when you're actually building these applications, they will respond to traffic load. They will respond to all kinds of policy things that you might build in your framework, and they will expand and contract as they want to. But for the sake of our demo today, we're actually going to create a need to go and expand our cluster. So let's come back over here, and we're going to clear out of here, and we're going to go back into Kubernetes, and we're going to create a new replica. So our replicas currently now are 3, and we're going to create a 4th replica. So we're just going to add that. The cluster is already scaled. So if we come back here and do a refresh, we will see that we've got 3 of 4. 4 of them are being built, so that will take just a second to do. And we can see it's already done. So if we come back in here to LinkerD, we'll be able to go back to our list of pods, and we can see that we have 4 available pods here. In just a second, you'll see the success rate go to there. So again, we're not doing anything into the service mesh to expand its capability. We're letting the application expand and contract as we need to, and the service mesh is going to follow. So that wraps up our demonstration. Okay, so let's continue moving on. So as I mentioned, LinkerD is a part of the CNCF, or the Cloud Native Computing Foundation, and that means it's open source. So when you are dealing with an open source community, you want to contribute to it. So LinkerD has an awesome community. So there's several ways of engaging with that community. So first off, everything we do in the CNCF world, we're doing pretty much against GitHub. So there's a GitHub project where you can go in and look at all of the tickets and all of the pull requests and all of the things that you want to do from a development perspective. A great place to get started is to join the Slack channel for LinkerD. So you can follow the link to slack.linkerd.io and go sign up. And that's a great place to go in and kind of watch what the community is doing. What's on their roadmap? What problems are they having? What use cases are they trying to solve? And so forth. And so that's a great place to go and get involved. Now the final thing we want to talk about is how can you get started today. So if you are running your own Kubernetes clusters, that's great. If you want to begin running your own Kubernetes clusters on maybe the public cloud, that's great as well. If you want to take a look at a Cisco product that actually deals with deployment of Kubernetes in a managed way, then we'll spend a moment talking about CCP, or the Cisco Container Platform. So the Cisco Container Platform is a turnkey container management solution, and so its goal is to allow you to run Kubernetes on pretty much any infrastructure. It is straight up upstream Kubernetes, but what CCP is doing for you is it's taking all of the weight away from you from having to go and deploy the control plane, figure out networking and storage and so forth. So it's there to automate the installation of not only the management cluster, but all of the clusters that you build from that point forward. The other cool thing about CCP is not only is it deploying this in your on-premises data center for Kubernetes, it also has the ability to reach out to AWS and deploy EKS clusters, Azure for AKS clusters, and coming soon, GKE clusters. So you can go into the single interface of CCP, deploy on-premises clusters and public cloud clusters and manage them from one place. So really quick, what does it look like to deploy a CCP environment? So the first thing you would do is once you receive the bits, you would go and deploy a control plane cluster on whatever hardware you're working on. So for example, today, you can deploy CCP right on top of a vSphere environment or on top of a HyperFlex environment and so forth. So once you deploy that control plane cluster, which is Kubernetes itself, you will then go from there and begin to launch tenant clusters. So these tenant clusters are where your real workloads are happening, and you can create multiple of these clusters, and they are basically treated as completely separate entities from one another. Now the reason I bring this up is not only is this cool because it really takes away kind of the headache of managing and operating the life cycle of Kubernetes, It also allows you to deploy the service mesh from inside this interface. So currently today, CCP supports Istio. That's that blue icon you see in that cluster ops screen, and that basically looks like the sailboat, and that's the icon of Istio. So currently today, you can go inside of CCP and enable Istio on your cluster from the UI itself. You can absolutely deploy LinkerD and other types of service meshes in there, but today, Istio is the one that's automated inside of CCP. So I encourage you to go take a look at that. Here's some references for you to gain access to what the user guide looks like and certainly what CCP does with Istio. So to wrap up here, it's really about the application, not the infrastructure. For so long, application developers have had to take on the platform operator role, where they are not only writing the application, the business logic of making an application alive, but they've also had to deal with logging and metrics and availability and security and so forth. Now, with service meshes, we can offload those things to maybe a platform team where their primary goal is to do those infrastructure components and then allow that application developer to focus on the application. We learned today that service meshes, from an application perspective, is there to inject these sidecars along with the rest of our microservice application and then manage the life cycle of those sidecars on your behalf. We also talked about the things that these sidecar proxies and the service mesh do for us are there to offload these service-to-service communication things, such as authentication and telemetry and so forth. And the final part here is that the best thing about these service meshes is that you do not have to create a one-off implementation of these things like security or logging for every one of your application. It provides uniformity across all of your applications. So you may have service A and service B doing two totally different things, but they can be based upon a common service mesh architecture that allows you to not have to recreate what encryption looks like or recreate what logging looks like. So this is a pretty powerful thing to look at and to go evaluate if a service mesh is right for you. So that wraps it up for us. There are going to be some URLs that have been posted on the screen. My name is Shannon McFarland, and you can reach out to me at IPv6, IEYE PV6 on Twitter, and I'd love to continue the conversation with you there.